Wow, that's a pretty big number you got there. Well, you're not going to be able to get anywhere having it stay in that form. Let me show you an easier way to use this in an equation. Today, I'm going to show you how to use scientific notation. It's basically a way of compressing large numbers so they're easier to work with. Let's take one of these numbers, for example, the distance from the Earth to the Sun, which is 150 billion meters. That's a lot. Now, you have to move the decimal, which is right here, and move it until it makes the whole number anything between 1 through 9. You can't have anything above 9 or below 1. Now, after you do that, you end up with a much smaller number. Now, you have to multiply it by 10, and however many times you move the decimal over is what number the exponent will be. Got that? Now, say that you have a decimal rather than a whole number, such as the total weight of a cellular protein, which is that number. It's basically the same process as before, but with a few differences. You move the decimal to the right rather than the left, and the exponent becomes a negative rather than a positive. Alright, say that you start out with the scientific notation first, instead of the whole number. You basically reverse the process. Let's use one of the previous examples. 7 times 10 to the negative 10. You would take the 7 and move the decimal over 10 times, or by the quantity of the exponent, and it'll become the original number. When the exponent is negative, move the decimal over to the left. When it's positive, move it to the right. Simple as that. Say that you have a notation like 57 times 10 to the 4th power. It's considered invalid because the whole number is over 9, which isn't allowed. So we gotta change that. Move the decimal over once in this case, so it becomes 5.7. But now that you've changed that, you have to change the exponent as well. Since you made the number smaller, you add the amount of times you move the decimal to the exponent. And now it becomes 5, basically saying if the whole number gets smaller, you increase the size of the exponent, and vice versa. Next thing you need to know is how to multiply and divide scientific notations. Say that you have 3.7 times 10 to the 5th power, times 5.1 multiplied by 10 to the 2nd. First, you would add the exponent, so that would be 5 plus 2, to get 7 to the 10th power. Then you multiply the first number, so 5.1 times 3.7, which is 18.87. So all you have to do in these cases is add the exponents and the decimals and put them together. Division is a bit different from multiplication, but not by a lot. Let's use the same numbers. So it would be 5.1 times 10 to the 2nd power over 3.7 times 10 to the 5th power. You would divide 5.1 and 3.7 and subtract the exponents from the 10, so you'd write it like this. So in division's case, divide the decimals and subtract the exponents. Kind of like the reverse of multiplication. There's more to come! Now I'm going to teach how to round numbers in scientific notation. It's quite simple really. Let's use 5.9342 as an example. All you have to do is either round up or down, and in this case you go up because the next number is above 9. It's basically the same as rounding a regular number. Alright, now here's the last lesson, word problems. These are even easier. It's literally just a scientific notation problem, but with more words. Here's an example. A band has released 2 albums. Their first album sold 5 times 10 to the 5th copies, and their second one sold 2 times 10 to the 4th copies. How many did they sell in all? So you would solve this like a normal multiplication problem. So you would multiply 2 times 5, which is 10, and then add the exponents, which is 9. So it would be 10 times 10 to the 9th. So after all this, you may be asking, why use scientific notation at all? Well, the definition is a mathematical expression used to represent a decimal number between 1 and 10, so you can write large numbers using less digits. Like I said in the beginning, it's a way of compressing numbers so they're not as much as a hassle to use. It can be used for plenty of things, including polynomials, or just for your own entertainment. And bam! You're done! Now that you have all of this information, you have no excuse to fail the next test we take.